Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called jump game. We were given an integer array nums and we're initially positioned at the array's first index, which is 0, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index, otherwise return false. Let's take a look at the example here. So we're initially positioned at the 0th index, which is here, and the number in the nums array represents the maximum length you can jump from here. That means standing from 0, you can jump to at most 2. Okay, so we're asked to return true or false to see if we can reach to the end of the array. So for this one, the result is true because we can start from here and jump to here and then go 1, 2, 3 and jump to the last index. Okay, and how about this one? We're initially positioned in here and we can jump 1, 2, or 3 steps. If we go 1 step ahead, we go here and the maximum length we can go is 2. So we jump and we're here, but this is 0. That means we can't go any further. Okay, so let's see if we can jump 2 steps here, and we jump 1 step ahead, still the 0, so we can't go. And then if we jump 3 steps, 1, 2, 3, we are here again. So that means we cannot jump to the last index from anywhere. Okay, so we should return false. So like I said, we can try this brute force idea all the time. So we can come from here and jump, then start from here and then jump, and let's see if we can reach to the end of this. Okay, so that will be very time consuming because we have at least like n squared time complexity for this. Okay, and for that we can see if we have the same sized array to store whether we can go to the final position or not, then we can save some unuseful calculations, like repeated calculations. Okay, so let's write it out here. So we can use something, some array called memo. We can record whether it's good or bad. So we can probably initialize a data structure called index. Okay, and we can use enum to represent the index. We can have good, also bad, and unknown. Okay, so now we have an array like this, and this memo should be the same length as nums. Okay, and next we can fill it with unknown. Okay, so probably I can do this. Index.unknown. Okay, and we can initialize our final result because we have to reach here. If we can reach here, it should always be good. So memo nums.length -1 equals to index.good. Okay, and then we can use a function to see whether we can start, whether we can reach to the final index starting from 0. Okay, so helper 0 nums. Okay, I'll use nums. Next, let's write the helper function. It's going to be a Boolean. So helper function, we're going to start at the position and nums. So if position equals to nums.length minus 1, of course we're going to return true, right? Yeah, so but not like that, since we're using a memo. Let's see. So if memo position doesn't equal to index.unknown, we have to know whether it's a good, right? So we're going to return memo position equals to index.good. If it's good, we're returning true, and false otherwise. Okay, so we have to read from the cache. Okay, like the memorization array. So next comes to our main function here. So what are we doing with this function? We want to know how far we can jump from our current position, right? So as long as it goes, we can count it out. Furthest we can go is math.mean nums.length minus 1 or position plus nums position. This is very easy to understand if we're standing, like, let's say if we're standing here and the number is 7, we're just one step away from the final position, right? So we don't have to use 7, but the length of the nums array is here. Okay, so we can't go any further. That's why we're going to find the minimum of these two. Okay, and after that, like I said in this example, we can start iterating from the from this, okay, from the next position to the furthest it can go. Like from here, we can go from 1, 2, 3. Okay, so now I will initialize something, position plus 1, and I will go furthest. Okay, we will iterate all the possible length that it can go. So if it can go, we're going to record the memo I to index.good, and we're going to return true for our function. Okay, otherwise, if we cannot, memo position will be index.bad, and we're going to return false from this function. I hope that's clear for you, and let's run it. Yeah, it looks like it works. So let's talk about the complexities for this. For time complexity, we are iterating all the positions here, and we're going to call the helper functions in the next level. So it should be n squared. Okay, and then for space, I think we're using this memo as a cache, so it should be length n, and the helper function will go as deep as n in the worst case, so it should be n space here, but since 2n equals to like n, okay, so this will be the final result of this function. Okay, let's see if it works. Yeah, perfect, it works. But is it good enough? No. N squared is still pretty large, okay? We can use something different as a greedy greedy solution. Okay, let's see. So suppose we're standing here, and if we go from the end to the start, and in any way, in any steps, I will see if I can reach to the final round, okay, to the final position. If I can, that means this is a good index and we can go further. If it can go to my current position, that means it can go to the final position. So this will be a good 2. We will just see if the last good index equals to 0. That means if we can go from the 0th index to the final position. Okay, so this, let me code it out. This is greedy, but we can understand this once I write it out. So last good position will equal to nums.length minus 1. Okay, last good, let me call it index, last good index. Okay, and I will start from last good index minus 1. Okay, or maybe nums.length minus 2 is larger than 0. I minus. So if I plus nums I is larger than last good index, if it's larger than or equal to last good index, then last good index will be I. Okay, and I will just check if last good index is 0. Okay, so if you don't understand this, let me write it out over here. Suppose we have 2, 3, 1, 1, 4, and here is our last good index. Is it good? Because of course it's good, because it's standing at the point that we want. Okay, and we start iterating from here. If it, so last good index is now 4. Okay, we have 0, 1, 2, 3, 4. Okay, so that's like the length of the nums array, but it's okay. Yeah, 1 smaller than the length of the nums array. Okay, so 4. If I plus nums I is larger than or equal to last good index, so for here we have 3 plus 1, which is 4, and it equals to the last good index. So now we have the last good index here, which is 3. Okay, and the next iteration, we're here, and I plus nums I equals to 3, which is the last good index. So a last good index will come to 2. And in the next iteration, I plus nums I will be, so 4, right? Is 4 larger than 2? Yes, of course. So our last good index will be 1 right now. And in the last iteration, I plus nums I equals to 2. Is it larger than 1? Yes. So our L is now 0. What I want to know is whether last good index is 0. So now here we have it. Okay. So in this case, we don't have to do the complex functions. And it will be on and o1 without any space. Okay, Perfect. Thank you so much for watching. I hope this video is helpful to you for your interview. And if you like the video, please like and subscribe to my channel. I'll see you in our next video.